Hey boys and girls, welcome to Chapter 12, Lesson 3. This is about box plots. So after today, you're going to know how to create a box plot and how to read and interpret a box plot. I find that most sixth graders, this is a new topic. Most kids have not seen box plots before. The good news is box plots use stuff that we've dealt with and worked with a whole bunch, like the median and quartiles, stuff like that. So let's get right to it. Box plot, the definition of a box plot is this. It uses a number line to show a set of data using the median, which we've done. You know how to find the median. It uses the median, the quartiles, so that's quartile 1 and quartile 3, and extreme values. So it shows the high value, the low value, and also outliers. A box plot is also known as a box-and-whisker plot. So I'm going to put that in parentheses. Or box-and-whisker plot. Whoops, P-L-O-T. So, box plot or a box and whisker plot. Those are the same thing. So let's highlight some of the key points there. So box plot, also known as a box and whisker plot. As we make one, you'll see where the word whisker comes from. So key ideas in the definition itself. It uses a number line. So you're going to create a number line. Something you should remember about a number line is it's got to have consistent intervals. You get to decide what they are, but they have to be the same number. Each mark or line on the number line itself has to be the same amount. And I'll show that when we build one. So it uses a number line to show a set of data using, you're going to need the median, you're going to need to find the quartiles, and extreme values. So a lot of that stuff we've done. The actual plot itself is what's new for most kids. Before we get to the example, hidden treasure's coming early in this lesson. Today's hidden treasure is inverse operations. I-N-V-E-R-S-E, inverse. In mathematics, what does that mean, inverse operations? So describe it, give examples of inverse operations. Okay, so the example we're going to look at is the length of coastline for 13 states along the Atlantic Ocean. So the length of coastline for Atlantic states. Okay, and here comes our data. So one state has 28 miles of coastline, another has 580, 100, 228, 31, 192, 13, 130, 127, 301, 40, 187, and another state has 112 miles of coastline. So I better have 13 numbers, since there's 13 Atlantic states. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. So we've got the right number of data values, 13. Length of coastline for 13 Atlantic states. Here's your data. Okay, so the first thing we're going to do is find the median, which you have done that before. So just as a reminder, the very first thing you have to do to find the median is you got to list your data values in order from least to greatest. So that's what I'm going to do up here. So carefully I'm going to read through and look at the data. The very least amount is 13. So I'm going to put these in order. 13. Next, and let's put a little mark by these as we do them. 13. 28 is next. Scanning through my data. 31. After 31 comes 40. After 40 is, I believe, 100. After 100, 112. After 112, we've got 127. After 127, 130. After 130, we've got 187. After 187, I'm looking at my list here because that's going to be faster. 192. After 192, we've got 228. And after 228, 301, and then 580. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so now I'm going to get a highlighter here, and I'm going to cross out till I get the very middle. That is our median. So I've got 13 numbers, so that means I can cross off 6 off both sides, and I should have 1 in the middle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this 127 is the median. $127 is the very middle of our data. Again, if we had 2 numbers in the middle, we would add them together and divide by 2, but since we have only 1 number in the middle, that is our actual median. So 127 is the median. Next, we're going to find Q1 and Q3, and we've done that before. So again, you do not include the median when you're finding quartiles. So I'm covering up this data, and I want the middle of those numbers there. So I'm not including the median. So this is what I would do next. I would cross out 112, 13, 40, and 28, and I would get 31 and 30 are in the very middle of the bottom half of the data. So then I have to add those together and divide by 2 for quartile 1. I do the same thing with the upper half of the data. So now I'm covering up the lower half of the data and the median. We don't ever count the median. So I do the same thing on the upper half of data. Cross out until I get the very middle, and on this side I have 192 and 228 together as the very middle. So now I go back and I'm going to add the two numbers together because I had 2 in the middle and divide by 2. So Q1 is going to be 31 plus 40 divided by 2. 31 plus 40 is 71, and 71 divided by 2 is 35.5. So that's Q1. Q3 is 192 plus 228. 192 plus 228 divided by 2. So when I put all that into the calculator, add those together and divide by 2, we get 210. So now we've got the median, Q1, Q3. In order to remember, for figuring out outliers, we need the interquartile range, and that is Q3 minus Q1. So leave a little space right here, and we'll come back to why we're going to leave that space in a little bit. So leave some space, and then we're going to calculate interquartile range. And that is Q3, third quartile, subtract first quartile, or 210, quartile 3, subtract 35.5. The interquartile range, distance between Q1 and Q3, turns out to be 174.5. That is the number we use to test to see if there are any outliers in our data. And remember, you take the interquartile range and you always multiply that by 1.5 times, or 1.5. So I take 174.5 times 1.5, type that in the calculator, and we get 261.75. This is the number we're going to use to see, do we have any outliers in our data or not? Well, remember, this is what you do. I look at quartile 1 and I go down 261.75. Okay? So I start at quartile 1 and I go down 261.75. And that's going to take me well into the negative numbers. My lowest number in my data is 13, so I do not have any outliers on the low side of my data. Quartile 3. From quartile 3, which is 210, I'm going to go that way 261.75. So I'm going to go from Q3 out 261.75. So I'm at 210. I'm adding 261.75, which takes me out to 471.75. And I look at my data, and it turns out I do have an outlier beyond that. I have a value at 580. That's beyond 471.75. So this, I'm going to put a little mark, or a star actually, right there on 580. That is an outlier. And it turns out when we make the box plot, which we'll do coming up, an outlier gets a star or an asterisk on your box plot. So that is an outlier. So again, all of this, the median, Q1, Q3, interquartile range, calculating outliers, all that is stuff we've done before. Here comes the new part, making the actual box plot. That's what we're going to do next. So I need a number line to do that. And my number line basically goes from 0, or real close, 13, all the way up to 600 would cover my data, because 580 is my biggest value. So my number line, I think a good range is to make a number line that starts at 0 and goes up to 600. All my data would be included. So now here's where, when you're making the number line, it's got to have consistent intervals. So drop down, give yourself some space. Here is our number line. And I'm going to call that 0. I'm going to count, I'm using my grid lines here. I'm going to count every 2 grid lines. I'm going to make that 100. So this is 100. 2 more grid lines, that's 200. 2 more is 300. 400. 500. And 600. So I won't need to go beyond, won't need to use all that, but now I've got a number line that I can use. Alright, so here's how you make a box plot. So this part is new. The first thing we're going to put on there is we're going to put a dot where the median is. Well, I kind of have to estimate where that goes. 127, this is 100, this is 200. Right in the middle would be 150. Right in the middle of these 2 lines would be 125. So really close to the middle between those 2 lines would be 127. Okay, so that is the median. And I'm going to put, actually I won't label this yet. Next, I'm going to label Q1 and Q3. Q1 is at 35.5. So again, I'm going to mark where's Q1. Here's 0, here's 100, here's 50. Halfway between 0 and 50 would be 25. So it's a little bit more than halfway on that line. So maybe like right there. Okay, next, Q3, 210. Well, here's 200. Here's 300, here's 250 in the middle, so it's going to be closer to this line, but it's going to be close, 210, right there. So now, from Q1, the median, and Q3, we make a rectangle. So again, when you make that rectangle, this line is the median, Q1, Q3. So now above those, I'm going to label. This was 127, that was the median. This is 35.5, that's Q1. And this was 210, that is Q3. So now let's go back and do some highlighting, just so we can really show how we created this. The median is 127. That's this line. That line in the middle of our box was the median. This box, or this edge of the box, 35.5 was Q1. Picking a different color. So here's Q1. Q3 was 210. That's how we got this line. That's Q3. Okay, now, the whiskers, so remember it was called box and whisker plot. Here's our box. The whiskers go out to the extreme values, the low value and the high value, but not including outliers if we have them. And remember, we do have an outlier on this side. This side we don't. So this side, the whisker just goes to 13. So 13 on my graph, it's going to be really close to 0. It's going to be about maybe like that. So I make a line and then I put a line like that. So there's a very short whisker. That's what this part is, the thing that sticks out from the box. Very short whisker on this side. On this side, I go out to the greatest value I've got, but not including outliers. So I'm not including 580. My greatest value other than 580 is 300. So the whisker on this side, here's 300. It's just barely off that line, 301. So my whisker on that side goes to there. My outlier gets a star on the Box-and-whisker. So here's 500, here's 600, 580 is going to be really close to 600. It's almost there. I'm going to estimate it to be about there. And I'm putting a star right there where my outlier is. So that's our outlier, 580. So this is a box plot. So now let me highlight a few things about a box plot. First of all, this box represents half of all your data. So half of all my data is between 35.5 and 210. The fact that this whisker is so tiny on this side means that my lower numbers are really clumped up, and they are. 13, 28, 31, 40, these are all really, really close to each other. Then they start to spread out a little more in the middle. 100, 112, 127, and then they spread out more on the high end of our data. That's why this whisker is so much bigger than this little tiny whisker. That whisker is 25, it's the lowest 25% of my data. This whisker is the highest 25% of the data. When it's spread out, that means those numbers are more spread out. If it's really scrunched together, like this whisker, that means the data's scrunched together, just like these numbers are. And again, if you have an outlier on either end or both ends, you'd specify an outlier with an asterisk or a star. So we did have an outlier at 580, that's it. That pretty much does it for box and whisker plot. So if you were given a box and whisker, you could tell what these things are. This is the median, that line. This is Q1. This is Q3. And then these are your extreme or lowest value and greatest value. And of course, keeping in mind there could be outliers. I meant to label this. This is an outlier. Okay. What you're going to be doing today is practicing making these and also looking at a box and whisker plot and coming up with what the lines mean. Median, Q3, Q1, low value, high value, not including any outliers. All right, that does it for box plots. I'll see you again soon for lesson 4.